Okay, here's warm-up number 45. All right, let's write this equation in log form. This is in exponential form right now. Log form, going to start by writing the word log. The base is going to be here it's the a. It's the thing that has something on its shoulder. It has an exponent on its shoulder. So the base is a, okay? The exponent is the part that's going to get isolated. So I'm going to leave a little space here, and the b is going to go over here. That means there's only one slot left for the c that goes in this position. So these two equations are equivalent. Here is the log form of that exponential equation. We're going to go the opposite direction here. We're going to write this one in exponential form. So the base is going to be d. The exponent is the isolated part. That's the f. And then the e would go over there. Okay? All right. These three problems, you can do all of these with a calculator, but only this one is in base 10. This one's in base 2, and this one's in base 125. Most calculators are going to use base 10. Some calculators you can put whatever base in. But if I wanted to do this in my calculator, I'd use change of base formula, which would mean I'd write this as log 16 over log of 2, okay? And you can type that into your calculator, but I can actually do this without a calculator at all. So if I write an equation like so, and then I put this in exponential form, this means 2 to the x is going to equal 16. And that's something I can do in my head. 2 to the second is 4, 2 to the third is 8, 2 to the fourth is going to be 16. So this log here is equal to 4. And if you type this into your calculator, you should get 4 out. Okay? When there's no base written, that means we've got base 10. So there's a little hidden 10 down there. And again, I could write this as log 10,000 in a calculator over log 10. But you actually don't need to do that because you could just type it in as log 10,000, hit enter, and it'll give you an answer. But let's just do this in our head. So 10 raised to the x equals 10,000. Well, that would just be 10 to the fourth because it has 4 zeros. So x is going to be 4 again. Okay? And if you just type in log 10,000 in your calculator, here, I'll hit log 10,000. Gives me 4, right? Okay, this one, again, I could do log of 5 over log of 125 to change it into base 10. But let's see if we can figure this out without a calculator. So 125 to the x is going to equal 5. Okay, now this is getting smaller, which means I'm going to be raising this to a fraction. Okay, now 5 to the third is 125, but if I raise 125 to the third, I get a really large number. It's something way bigger than 5, right? So what I'm going to do, I'm going to think about the opposite of raising to the third would be raising to the 1/3, okay? And 125 raised to the 1/3, that's the same as taking the third root of 125. And 5/4, 5 times 5 times 5 is 125, right? So that means x would have to be 1/3. Okay. All right. Next, let's write this in base 10. So, if I did the same kind of thing as the last problem, tried to do this in my head, 7 raised to the x equals 13. Well, 7 to the second is 49, 7 to the first is 7, so it's going to be a decimal, okay? So writing this in, I'm going to write this as log of 13 over log of 7. Often I see people get this fraction flipped upside down. So you see how the 13 looks like it's higher than the 7? That's how I just remember the 13 goes on top, the 7 goes on bottom. Okay? And now I just type this into my calculator, log of 13, and close the parentheses. Otherwise, your calculator will get confused. So I close the parentheses and then divide that by log of 7. It doesn't really matter if you close the parentheses on bottom, but you've got to close it there. Otherwise, it'll take the log of 13 over log 7. We don't want that. We want log 13 over log of 7. And that gives me about 1.3, I'll call it about 1.32. Okay, and this is telling me that 7 raised to the 1.32 roughly is 13. Let's try it. 7 raised to the, and I'm just going to, I'll use 1.32. It's not going to be exact because this is rounded. If I use this whole decimal, it'd come out exact. But that's pretty close to 13, right? Okay. All right. So next up, we could do this by trial and error, but it would take a long time. So let's write this as, let's use logs to do this. I'm going to write this in log form. My base is 4. Okay, the x is going to get isolated, so that means the 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to go like that. Okay? And then I'm going to type this into my calculator like this. My calculator can only do base 10. Okay, so let's see what we get. Okay, close the parentheses and divide by log of 4. And I've got 13.44, I'll call that roughly. Okay, all right, same kind of deal on this last one. This is going to be log base 13 of 987654321 equals x. And I'm not going to rewrite that, but it's the log of the big number over log of 13. I'll just put it straight in my calculator here. Log of 987654321. Close the parentheses and divide by log of 13. And I've got 8.07. Okay, and that is the end of the warm-up. See you next time.